Okay, today's class, it's Friday, will be mainly about sketching the graphs of the inverse trig functions. Okay, all right, so let's start. First, we know all the restrictions, so let's sketch everything. So we have y is equal to cosine of x, which we restrict from, so we make this the domain from 0 to pi, and the range is -1 to 1. So let's sketch this. And so let's do 0 to pi. Okay, it's 1. And that's the graph, right? Cosine. Okay, so let's use this to sketch the inverse. The inverse will be a reflection over the line y is equal to x. And the best way to sketch it, 0, comma, that's 1, right? 0, comma 1 will become 1, comma 0. Right? Pi over 2, comma 0 will become, let's actually sketch it on a separate one. So let's do it this way. So the x, which was going from the x that was going from 0 to pi will now be the, from 0 to pi will now be the y, which is going from 0 to pi. And the y, which was going from -1 to 1, will now be the x, which is going from 1 to -1. Okay, and now we can just flip these points. 0, comma 1 will become 1, comma 0. Pi over 2, comma 0 will become 0, comma pi over 2. Pi, comma -1 will become -1, comma pi. Okay, and you can see this piece kind of gets flipped back this side, and this piece will go that way. So it'll look like this. This is the shape of inverse cosine, right? So our y is equal to arc cosine. Domain, -1 to 1, and we know the range, it spits out an angle from 0 to pi. Okay, now let's do the graph, restricted graph of sine of x. And sine of x, we said we will restrict it from -pi over 2 to pi over 2. And we know it's 0, and pi over 2 it's 1, and negative pi over 2 it's -1. That's the restricted sign, where the domain is from -pi over 2 to pi over 2, and the range is from -1 to 1. And now let's sketch the inverse. Sketch the inverse, where the x is now going from -1 to 1, and the y is going from -pi over 2 to pi over 2. Okay, and let's use these, reverse these points. So pi over 2, comma 1 will become 1, comma pi over 2. 0, 0 stays 0, 0. And -pi over 2, comma -1 will become -1, comma -pi over 2. Okay, and we can see the flip is sort of across the y is equal to x. So it'll look like this. Is This is the graph of y is equal to arcsine of x. Okay, domain -1 to 1, range -pi/2 to pi/2. Okay, the third graph. Let's do the graph of tan of x, and then its inverse. Okay, we know we restricted tan of x very naturally again, just like sine of x from -pi/2 to pi/2. But here at the ends we have the vertical asymptotes. Okay, and 0 at the halfway point at pi/4, it is 1. And they're just giving the shape -pi/4. It's -1. And that's the graph. Okay, now let's sketch the inverse. It's kind of, let's write actually the domain and range for tan of x. So the restricted tan, the domain is -pi/2 to pi/2, not included, not inclusive of the endpoints. And the range is -∞ to infinity. Okay. So now we know for the inverse function, the domain is -∞ to infinity, right? So let's do it this way. So x is equal to -pi/2 and x is equal to pi/2. The vertical asymptotes will become horizontal asymptotes. So here is y is equal to pi/2, y is equal to -pi/2. Let's flip the point. 0, 0 will stay 0, 0. Now, this is the easiest way to see what's going on. As x is headed to pi/2, right? The angle is going to pi/2, y is going to positive infinity. So we switch it as x is going to infinity, so x is getting bigger, y is headed towards pi/2. Oops, I don't know what happened here. So it's this way, right? And look in the negative direction, what's happening is x is going towards -pi/2, right? Y is headed towards negative infinity. So now when x is going towards negative infinity, correct? Y is headed towards -pi/2. This is the lovely graph of arctan of x. So this is y is equal to arctan of x. And we know the domain is -∞ to infinity, and the range, it only spits out an angle from -pi/2 to pi/2. Okay, number 4 on the list. This is a cool one. We're going to use this because we haven't done this graph before, but you will need to know this also. It's a graph of cotangent of x. Now remember, cotangent of x is the reciprocal of tan of x, right? Cot of x is 1 over tan of x. So let's sort of use the graph of tan to sketch the graph of cotan. Okay, so this one I'm going to go from 0, and we're going to only sketch it in the interval from 0 to pi. So this one, let's extend it a bit, is, or let me mark it, sketch the graph here below of tan so you can sort of see it, what's going on. Tan at -pi/2 and pi/2, we have our vertical asymptote. This is the graph of tan, right? 0, pi/2, this is well, this is pi. Okay, 0, pi/2 pi. Okay, and this would be tan's period is pi, right? So 0 will repeat 0, and this piece will repeat here. Okay, now look what's happening. The tan graph for the cotangent graph. At x is headed towards as x is getting closer to, well, let's put it this way. Uh, as x is headed, how can I explain? Okay, slowly. As x is getting closer to 0 from the right-hand side, correct? What is happening to the y? Y is also getting closer and closer to 0. Okay. Um, so what will happen to the flip for cotangent? So as x is getting closer to 0 and y is getting closer to 0, so that means for cotangent, it's becoming 1 over smaller and smaller numbers, right? Remember we talked about that before. So this is 1 divided by smaller and smaller numbers. Smaller and smaller numbers is equal to bigger and bigger numbers. So this side we are going to positive infinity. So we have actually an asymptote at 0. So this is a vertical asymptote. X is equal to 0. Okay. Now what's happening is x is headed towards pi over 2 from the left. What's y headed to? Well, it's 1 divided by bigger and bigger numbers, which is smaller and smaller numbers, and we are headed actually to 0. So at pi over 2, we're going to be actually at 0. Okay, so this is cotangent. And here you can see as x is approaching pi over 2 from the right-hand side. Okay, x is approaching pi over 2 from the right-hand side. That's 1 divided by bigger and bigger, so that's going to 0. And as x is approaching pi, right, y is headed towards 0. So x is heading towards pi from the left, y is getting closer to 0. So 1 divided by smaller and smaller negative numbers is bigger and bigger negative numbers. So this side we are going to negative infinity. So this is the graph of cotangent of x. So let me redraw it here so that we can have it. So y is equal to cotangent of x. I'm doing the restricted, so one period which we'll use, which is 1 to 1, so we can make the inverse. And we are going from 0 to pi. At 0 and at pi, we have vertical asymptotes. So remember, it's basically like it's like a tan graph, right? Cotangent is just like a tan graph, but it's shifted and flipped over the x-axis. So this is the cotangent graph. Okay. Domain for the restricted one, domain is from 0 to pi. So you have to remember this. Cotangent is 0 to pi, not inclusive. And the range is negative infinity to infinity. So we know for our inverse function, arc cot of x or cot inverse of x. The domain is all real numbers. And the range is, it's going to spit out angles from 0 to pi. So here is, so I should actually make this a little lower, easier to see. So over 2 and pi. Okay, the two vertical asymptotes will become two horizontal asymptotes. We have a horizontal asymptote y is equal to 0, and the other one is x is equal to y is equal to pi. Okay, and let's see, let's look at this. When so we can at least use 1 point. Pi over 2 comma 0 will become 0 comma pi over 2. So it's a nice point to have, right? And let's see now, as x is headed towards pi, y is headed to negative infinity. So the flip will be when x is headed towards negative infinity, y is headed towards pi. So this side it looks like this. Yeah. Then we see when x is headed towards and x is headed towards 0, correct, from the right, y is headed towards positive infinity. Now, when x is in the inverse function, as x is headed towards positive infinity, y is headed towards 0. This is the graph of arc cotangent of x, or arc cot of s. Domain negative infinity to infinity, and the range is from 0 to pi. Okay, and finally for the last two, which ones will be secant and cosecant. Okay, so going to remind ourselves again, graph of cosecant of x. Okay, now purposefully I'm going to draw it actually in the interval. So remember that cosecant is the reciprocal of sine. So I'm going to draw pretend sine first from negative pi over 2, okay, to pi over 2. Okay, and that's the, so see that's the regular, that's our restricted sine graph anyway, and cosecant would be flip of that, right? Pieces. 1 divided by smaller and smaller number positive is bigger and bigger positive, and negative pi over 2 it's negative 1, and then this side is going towards. Okay, so cosecant x restricted. The restricted, see, this is a one-to-one function, right? The domain, what's the domain? It's from negative pi over 2 to pi over 2. But what's the number we have to skip over? There's a vertical asymptote, x is equal to 0. So this is going to 0, union 0 to pi over 2. So it's actually easy way to remember cosecant of x graph. Cosecant x graph is basically from the restricted sine graph. Negative pi over 2 to pi over 2. Cosecant and sine related. Negative pi over 2 to pi over 2. Okay, but only thing here, there's 0 is not included. See, we have a vertical asymptote at 0. And the range, as we done before, is negative infinity to negative 1, union 1 to infinity. So let's do the inverse. So arc cosecant of x. Arc cosecant of x. So remember, x's and y's flip. So now we have, instead of going from negative pi over 2 to pi over 2, we'll do that in the y's. Negative pi over 2 to pi over 2. The vertical asymptote x is equal to 0 will become the horizontal asymptote y is equal to 0. Let's use a nice point. Pi over 2 comma 1 will become 1 comma pi over 2. Okay, and negative pi over 2 comma negative 1 will become negative 1 comma negative pi over 2. Okay, now let's see the behavior. As x is going towards 0, y is headed to infinity, right? So in our case now, as y is headed towards 0, y heads towards 0 as x goes towards positive infinity. Boom. Okay. And what about the other side? As x is going towards 0 from the negative side, right? Y is headed to negative infinity. Okay. So as x is headed towards negative infinity, y is headed towards 0. And this will be nicely the graph of arc cosecant. Cool stuff, right? Finally, the last one. Let's sketch the graph of secant of x restricted and Just remember secant of x, cosecant of x restricted, same as restricted sign, negative pi over 2 to pi over 2. Secant of x restricted, same as cosine restricted, that is from 0 to pi. So let's restrict cosine from 0 to pi. Okay, and this would have been the graph of cosine, right? So we know the secant is the flip. So 1 divided by smaller is bigger. 1 divided by negative 1 is negative 1. 1 divided by smaller negative is bigger negative. So this is the graph of secant of x. The restricted domain is going from 0 to pi, but we got to jump over pi over 2. There's a vertical asymptote there. Okay, and the range is going from, as you can see, it's just like before, negative infinity to negative 1, union 1 to infinity. Secant of x. So let's now sketch y is equal to arc secant of x. Okay, so instead of going now the x going from 0 to pi, now my y will go from 0 to pi, right? And let's use these, we have a vertical asymptote at x is equal to pi over 2 will become a horizontal asymptote at y is equal to pi over 2. Okay, the point pi comma negative 1 will become negative 1 comma pi. The point 0 comma 1 will become 1 comma 0. Okay, and let's see, as x is headed towards pi over 2, y is headed to positive infinity. So as x is headed towards, in the inverse, as x is headed towards positive infinity, y is headed towards pi over 2. Boom. And similarly, as x is headed towards, you can see here, as x is headed towards pi over 2 from the negative side, from the positive side, this was from the negative, y is headed towards negative infinity. So as x is headed towards negative infinity, y is headed towards pi over 2. That's it. That's the graph of arcsecant. And for arcsecant of x, again, the domain is going to be the range of the original. So that's negative infinity to negative 1, union 1 to infinity. But we care also the range more importantly. The range is just going to be the range of restricted cosine, which is from 0 to pi. Okay. For skipping, remembering to skip over, I forgot to put that in, sorry. Remembering to skip over pi over 2. The range is from 0 pi over 2 union pi over 2 to pi. That's it. Okay, let's do like one problem. I'll do one kind of cool problem. Let's do one example. I'm giving you y is equal to 5 cosine of 2x. First part, find, so let's call this, say, f of x. Find f inverse of x. Find the inverse function. And b is sketch one period of the inverse function. Nice problem, right? Okay, so we know to find the inverse function, first y is equal to 5 cosine of 2x. We switch the x's and y's. And our goal will be to solve for y. First, divide by 5 on both sides. So cosine of 2y is equal to x over 5. And then we call on the inverse function. So cosine of an angle spits out an output. Arc cosine takes in that output and gives you back the angle. So y is equal to 1/2, dividing both sides by 2 or multiplying both sides by half, half times arc cosine of x over 5. So this is our inverse function. Nice. Okay. Now let's sketch it. So what we will do is first we will just sketch, let's sketch 5 cosine of 2x. Okay, one period. And let's see, cosine of 2x. So 2x would going from 0 to 2 pi, or you could have used again period is equal to 2 pi over b. So our b is 2. So we complete 2 cycles in 2 pi. So 1 cycle in pi. So the period is pi. Quadrant length is pi over 4. Or we could have done it this way, set 2x between 0 and 2 pi, divide through by 2. So the period is pi. Okay, there's no horizontal shift. So let's start this one at 0. And we are going pi over 4, right? Pi over 4 and 2 pi. Pi over 4, that's pi over 2. Okay, and I'm going to draw a cosine graph. Let's 5, 1, 2. I'm going to pretend 5 is here. Okay, 5 and 5. That's it. First quadrant down to the middle, second quadrant down to the bottom. And that we've completed, as you can see, one cycle, right? This is 1 to 1. And now we've got to just invert this guy. So this is y is equal to cosine of s, cosine of, sorry, 5x restricted. Okay, not 5x, sorry, a mistake. This is the graph of y is equal to 5 cosine of 2x. Okay, let's flip this. So now we can flip it. So what was the x's were going from 0 to pi over 2. Now the y's will go from 0 to pi over 2. With these, so pi over 4 and pi over 2. Okay, 0 comma 5 will become 5 comma 0. Correct. Pi over 2 comma negative 5 will become negative 5 comma pi over 2. Okay, and pi over 4 comma 0 will become 0 comma pi over 4. And we have the graph of, this is the graph of y is equal to half cosine inverse of x over. Okay, that's it. And we'll stop.